Hi, today we'll be covering the Oracle SQL conversion functions. So there are two types of data conversions in Oracle SQL. First is implicit and second is explicit. Implicit are automatically done by Oracle SQL and explicit are where we specify Oracle to convert the data type to a certain type. So moving to the first implicit data conversion, so this Oracle SQL automatically converts the following from varchar to or char type to a number data type or a date data type. A date data type is converted to varchar2 type and number is also converted to a varchar2 data type. So these are the data conversions which we are generally unaware of and Oracle automatically takes care for us, and rather we should be very careful using these implicit data conversions. So we'll see a few of the examples where Oracle is implicitly converting the data. So first is text literal example. So suppose if I go ahead and do this, select salary plus 10 from hr.employees. So we should generally expect an error because salary is a numeric data type and 10 here is a string data type. So these two are incompatible data types, but Oracle does the implicit conversion for us and this query runs perfectly fine, just like we would have run this query. So the database used here is HR database and the environment is Oracle Live SQL. You can directly go to your browser and open livesql.oracle.com. Okay, so second example is character and number value example, and then we'll see one date example. So here we see that we are doing a last name search from employees table where employee ID is 200 and 200 is being put in as quotes as a string. So if we run this query, so there we get the record. So we should be really careful here that when an implicit conversion is done for a string to number, they are taken by Oracle SQL, and if we put an alphabet in this, so it gives us an invalid number because 200A is not a valid number. So we should be careful of these things. Using this or in 200 as whole is perfectly fine. With the dates, we have been doing this since long, but we are unaware of this conversion. So if I do select last name hr.employees where hire date is greater than 3rd of March 97, if I run this query, I get the results. So in case I was to do it without this quotes here, it would give me an error because the March here is an invalid identifier. So this should be either of a date data type or this string is automatically converted here to date data type. So we can let Oracle do the conversion of this type to a date to match the higher date data type. Now let's see why we should avoid using implicit conversions. So for this, let's create an example. I'll reset the session. Now moving to why we should be not using implicit conversions, let's create a table called as birth. Now the table is created. If we do select star from birth, we can see it has the following data. Now in case I wanted to do the age difference between Nids and panda, and their date of birth is 12 Jan 58 and 14 Feb 48, so we should be expecting a positive number of dates, but this is not the case. The Oracle SQL implicit conversion has done a blunder for us, and you can see here the date difference is minus 32905, and this signifies that 12 January 58 and 14 Feb 48. So 14 Feb 48 is a greater date than 12 Jan 58. To check why this is happening, let's uh, see first the default date format. So there are certain analyze session parameters which are set in your session. So just see what is the date format in analyze session parameters, and we see the date format is dd hyphen mon hyphen rr. So that's date, month, and the last two digits of your year. Now, there are two things. One is RR and one is YY as the year format, which creates a huge difference when you are saving the dates. And this all happens just as one example of implicit conversations. Now, if I'm storing my date as 4-digit characters for the year, then there's no issue. It is saved as the exact year. So there's no issue in that. But what if I was to store only the last two characters? I am passing the last two digits of the year. So when the format is RRR and I'm passing the last two digits of the year, the number which is less than 50 will be stored as the current century, which is the Y2K format, and the number which is greater than 50 will be stored as 1958. So this 58 year is stored as 1958. So RR was introduced by Oracle SQL to resolve the issue for Y2K years. Now with YYY it is a bit different. When you go ahead and you save your year and the format in your session is MMDDYYY, and they are storing for expecting the 4 digits of the year, and you pass the value as 48. So Oracle automatically expands 00 to it. Whatever its value, less than 50, greater than 50, it assumes you have not passed anything and it is by default 00. Same is the case with 58. Either the value is greater than 58, 50 or less than 50, it doesn't matter. But the format when you have given is YY and you are passing 58, the current century is taken into account and Oracle stores is at 1st January 2058. Either the value is less than 50, greater than 50, doesn't matter. It will assume it to be the current century. Now, what if I am modifying this format of my session and I change it to DDMMRR? Or what if the current session is changed by some other user who is sharing the session with you and they change this format? So let's see what we have currently stored. So our data is 1958, 2048, 1958 and 2048. Now here we can see that the date of Nids, which was 12th of January and slash 58, is basically stored as 1958, and the date birth of panda, which is 14 Feb slash 48, is stored in database as 2048. That's why the difference between these two dates was negative. In case we had the default format as YYY being set in the session when these records were added to the table, this difference would have been a bit different. So let me change the format to YYY and again do this date difference. So you can see now that 12 January 58 and 14 Feb 48 is now considered as 12 January 2058 and 14 Feb 2048. So that's why the age difference is 3,620 days, so, which is a correct calculation which we were expecting to be. So this is certain things that you need to take care of when you are saving your data or updating your data. These issues might occur because if you tend to update your data for say this record for 12 Jan 1958 and my session has a date format for DD, MO and YY, and I store it as say instead of 12 Jan as 13 Jan, I say 13 Jan slash 58. It would now be stored as 12 Jan 2058 because the date format here is DDMON and YY. So YY, if value is less than 50, greater than 50, doesn't matter. It stores it as the current century 2058. So this is something we should be careful of. And this is just one example with the date implicit convergence. You should be very careful with other implicit convergence as well. So that's why we should always avoid using the implicit convergence and rather use explicit convergence when and wherever possible. So moving to the explicit data conversions, we have different functions available from Oracle SQL. So you can convert a character to number using toNumber function, character to date using toDate, a date to character, and a number to character using to_char function. So let's go to some of the examples of toChar, and it is used to typecast a numeric or date input to character type with a format model. And the syntax is to_char. It takes input a number, a format, and the NLS parameter which you want to set. So we have just seen previously session parameters for NLS which you can utilize in here. Similarly, toDate, it converts, takes the character values and puts and returns the formatted date equivalent of the same. So the syntax will be to_date string1 format mask and NLS language. So for example, select toDate. We are converting this date to YYYMMDD format. And instead, if you want 5 Jan 2017 to be stored as a format of DD, MON, and YYY. So it's completely up to us. You can enter any type date in any format in the string value and store it, convert it to date to match your data type of the table, because the input might be coming in different formats. So you want to take care of what your input is, because if this is the input and your format happens to be DD MOMYYY, it would have given an error for wrong date which you have entered, which is 2012, because it was expecting the first two digits to be date. The third function is toNumber, which converts a character value to a numeric data type, and this is where a user faces a lots of error. Now, if a table is containing a data type or a column which is numeric, you should store it as a number data type. You should not be storing it as a string or a varchar data type or a character data type. This is something very important, and you might face errors in later, because if you are trying to convert a string value to a number value, convert a string value to number value, it will give you an Oracle 01722 error. And this is the most common error which a developer faces when doing such kind of operations or handling their data. So Oracle strictly specifies that if you are storing a number data type, don't use it or save it as a string data type, because you might end up storing some number which contains string in it, and at later stage in future you might want to convert that string to number to do some of the calculations, and you will end up having an error like Oracle 01722. So quickly moving through the examples for conversions. Now here is, let's say I want to do select first name, and I want my hire date to be given in month DDYYY format, because currently the dates are given in this format and I want them to be in this format, and I want my salary to be in dollars, so I just give salaries dollar 999.99 two decimals format from employees. So as you see here, the numbers are converted to 24000.00, because there's no decimal point value to the numbers in the database, so every value is 0.00. And a dollar is automatically appended because the salary, which is a number data type, is now converted to char when you are represented with this view. And date here you can see is in month June DD17/2003 format. If it happens to be a YY, it will change the date format to 0301, the last two digits of your year. So you can quickly handle it around. If you want only the first three digits of your, you can do it month. So you will see June, Sep, only the first three characters of your month. So you can convert a string to character which contains only digits, or you can do this as well. Now here you need to take care, because 0110 plus 1. Now as per the rules, the bracket things will happen first. The Oracle will calculate the value of this bracket, and Oracle will implicitly convert this 0110, which is currently a string, to a number and then add 1 to it and then convert it to a character. So here you see this is 111 plus 1. So that's why you should be very careful with it, because the two character value of 01100 is 01110. But here, because Oracle is implicitly converting the data and you have specifically specified it as a number or to be converted to a character, it's taking the character value for these functions. Similarly, you can convert a string to any date format of a choice and a number to any format of a choice. So next we will move on to casting. Cast is a function which is having more features than toNum, toChar, or toString. In cast, you can specify any data type uh, just like this. You do select cast. You want to convert this date string as a varchar from a dual. So when I run this query, this is an invalid statement. I'm sorry, forgot to select. So here you see that 22 August 2003. This is implicitly converted to date, and you want it as a varchar. You don't want it as a date. So this is simply converted, casted to a varchar type. Now if you want to cast a string to a number, you just simply put cast this string as number of 2 precision. So when you select this and run this, the result is 245.21. Now you must take a note here that the result 245.21, it's not a rounded value, it is truncated. It is not truncated to only 2 decimal type. You are rounding it off to 2 decimal places which you have specified in here, because a number is always rounded off when you specify more than 2 decimal places to it, and you have precision of 2 decimal places. Now if you want to cast this number to dual table, you see that 205 is 21, it's not 20. You cast 1 2 3 4 5 6 as number and then add 5 to it. So this is something which you should be following and not using the implicit conversions. So you can convert this to a date as well and add 5 to it. Now this is an invalid one because my current date format is different, because this is the default format and I'm not using this format. If I use DD month and year format, it gives me a correct value, because currently I'm using a month format for here. So if I have happened to enter a month in MON or MONTH, Oracle would have taken it as a correct value, but instead it was a 05 here, and 05 is not a valid month. It says it's not a valid month because our default date format specifies a date in DD format, a month in MON format, and year in YY format. You can cast system date to timestamp as well. So system date will be system date and timestamp. If you want to select only the system date, I would be typing select sysdate from dual table. So this is the system date, but you want it to be a timestamp. You run it as timestamp. So it is very handy function and very used very frequently to convert a data type to any data type. So you can avoid using toChar, toNum, toString, tobinary. There are a lot of functions, and you can use cast to convert a data type to any data type of your choice while performing these operations or getting the data from your records.